this video is going to be looking at the sample assessment papers for the International Advanced Level Chemistry from Edexcel, and we're going to be focusing on Unit 1, and we will be looking at the multiple choice section. So section A is the multiple choice, and that is a total of 20 marks out of the overall 80. So for the multiple choice, we should be aiming to spend no more than 20 minutes on this section. Please remember that the marks break down to roughly 1 mark every minute. So the first question is giving us some information about the periodic table. And the letters in it, of course, are not the normal symbols, but we're going to use these to then answer the questions. So where I would start with this would be label the diagram that we've been given. This makes it just that little bit easier for us. So we can label the groups first of all. So we have group 1 and 2. We've got our transition metals in the centre. Then we've got groups 3, 4, 5, 6, 7 and 8. We can also label the periods, and please remember that the helium that would be on the top of the noble gases, that is the first period. So period 1 is there, and then the line beginning with R is period 2, and then 3, 4 and 5. And we can also label the blocks. So we've got the S block, which are the first two. Our transition metals fall into the D block. And remember, the blocks are where the highest energy electron is. And then groups 3 to 8 are known as the P block. So for question 1A, which elements are in the S block of the periodic table? This is now very simple because we've already labelled it. And we know that the S block is the first two, therefore our answer must be A, which is elements R and U, because they are found in group 1 and group 2. For part B, we're looking at which element has 4 occupied quantum shells. Well, that tells us that it must be in period 4. And that has 6 electrons in the outermost shell, so that tells us that it must be in group 6. So now I go to period 4, and I go along until I get to group 6, and my answer must be Y. Part 3 is looking at which pairs of ions have the same electronic configuration. Well, we have to look to see what they would form. So if we have R, we know that that's going to go back to be similar to helium, whereas T is going to be similar to our neon. So if we just write in that we've got helium, neon, and argon, they would be the main noble gases. So R would go back to helium, whereas T would go to neon. So it can't be A. We then look at T and Y. So T could go to neon, whereas Y would go down to krypton. So again, can't be those two. We then look at U and T. Well, T would be similar to neon, and U would also lose 2 electrons to be neon. So our answer is most likely going to be C, but let's just double check that it's not D. So we've got U, which would be similar to neon, and W, which will be the same as argon. So our answer here for the same electronic configuration must be C. For question 2, we're looking at phosphorus and sulfur. So which species contains 15 protons, 16 neutrons, and 18 electrons? Well, we can work out a number of things here. We can look at the mass, we can look at the atomic number, and we can also look at a charge. So our atomic number is always the number of protons. So that's going to be 15. And when we check our periodic table, we know that 15 is phosphorus. So that automatically gets rid of C and D. Our mass is going to be the protons plus the neutrons. So 15 plus 16 giving us a mass of 31. And our charge is going to be the difference between the protons and the electrons. And I have 3 extra electrons, which means I have 3 extra negative charges. So this must be P3 minus. So my answer has to be A. For question 3, the electronic configuration of nitrogen. Well, you can go to the periodic table and you can find that the atomic number of nitrogen is 7. So going back to our GCSE, we would write that out as 2, 5. but now we can write it in our S and P notation. So we know that we have 1s2, 2s2, and then the remaining electrons go into the 2p, which is 3. So that automatically gets rid of A and B, because our 1s and our 2s are not completely filled. So that leaves us with C and D, and we have to remember that each electron fills the orbitals individually before they pair up. So in other words, we would never have an empty orbital like this. So it can't be C, and our answer must be D. For question 4, we have a sample of neon that contains a number of isotopes. So we have neon 20, which is 90.9% abundance, neon 21, 0.26, and neon 22, which is 8.82. And we want to find the relative atomic mass of neon to 2 decimal places. Well, this is actually a GCSE question. It's just expanded to have 3 isotopes, so we can work out the atomic mass by doing the mass times the percentage abundance plus the mass of the second isotope times the percentage abundance, and the same for the third isotope. And we can divide that all by 100. You can plug all those numbers into your calculator and you get an answer of 20.179, but of course we want it to 2 decimal places, so that's going to be 20.18, making our answer C. And we know that it's more likely to be 20 than it is 21 or 22 because our percentage abundance of the 20 is very high. But it can't be exactly 20 and it can't be exactly 21. For question 5, we've got some information from a mass spectrum. So we have a sample of pure iron, very important that it's pure, and is given in the table. And we've got some mass to charge ratios and the peak heights. And we want to know which species is most likely to cause the peak at the mass to charge ratio of 28. Well, we can automatically get rid of C and D because these would only be possible if they were impurities, because we're told that the iron is pure. So it cannot be the silicon or the strontium. So that leaves us with Fe2 plus with a mass of 56 or Fe plus with a mass of 28. Now, we cannot have a mass of iron which is 28. It has to have the number of protons and neutrons. And our iron has 26 protons. There is no isotope of iron that can only have 2 neutrons. So it cannot possibly be A. So by process of elimination, that leaves us with B, but we can double check that by checking the mass to charge ratio, because the mass is 56, the charge is 2, and that gives you a value of 28. So our peak must be being caused by B. For question 6, which of these is not a chemical reaction? Well, we have to look to see what each of them do. So cracking, its purpose is to break down long chains. So we are breaking bonds and making it into smaller molecules. Fractional distillation is a separation using boiling points. Polymerization is used to combine monomers. And reforming creates a ring structure or creates branches. And the purpose of a chemical reaction, the way that we can define it here, is that we get some form of breaking of bonds. So cracking, polymerization, and reforming all have breaking of bonds. So our answer must be, again by process of elimination, fractional distillation. For question 7, we're looking at fuels that are obtained from fermented sugarcane. And this one hopefully is a nice easy question that you don't even really need to think about. Fermentation can only form ethanol. So our answer right away, you should be thinking ethanol. Propane and petrol can come from fractional distillation and cracking, and hydrogen can come from cracking as well, whereas ethanol comes from taking the glucose and sugarcane and fermenting it. Question 8 is looking at a systematic naming method. So we've got a compound that contains a double bond plus a chain, and we have to figure out how we name this. Now, our main force here is that we have to have the double bond on the lowest possible number. That means our numbering must start from the right-hand side. So we have carbon number 1, 2, 3, 4, 5, and 6. This means our chain has to be on carbon number 5 and our double bond is between 2 and 3. So that automatically gets rid of C and D. Now we just have to figure out if it is an E isomer or a Z isomer. So we have to look at where our R groups are. And we have an R group at the top of the double bond and an R group at the bottom of the double bond. So when they are on opposite sides to each other, they are enemies, and the E in enemies tells us that it is an E isomer. So our answer must be A. For question 9, we are looking at the reaction of ethene with bromine to form 1,2-dibromoethane. So we're getting some sort of addition reaction happening here. And for the ethene molecule, we want to think about what type of bond is broken and what the bond fission is. Well, we know that we're having to break this double bond, and all double bonds are made up of a sigma and a pi bond, but it is the pi bond that breaks. Remember, we do not break the sigma bond here. So again, that can get rid of C and D. And we have to think about what type of bond fission. And because we have the Br forming ions, that must be heterolytic bond fission, because homolytic fission would give us free radicals. So our answer here must be A again. Question 10, now we're looking at some calculations. So we have got 0.045 grams of solute and 1,500 grams of a solution, and we want to figure out the concentration in parts per million. So we're going to figure it out by taking the mass of the solute divided by the mass of the solution, and we multiply it by 1 times 10 to the power of 6, or by 1 million. So we've got 0.045 over 1,500 times 1 times 10 to the 6, which gives me an answer of 30.0, and of course there it is, the answer being C. For question 11, we want to figure out the concentration in moles per decimeter cubed of a solution containing 7.84 grams of phosphoric acid and 400 centimeters of solution. So the way that I like to approach these is write down everything you have. So you have a mass is 7.84. You want to find the concentration, and you know your volume is 400 centimeters cubed, or 0.4 decimeters cubed. So when you think about your triangles, you've got your mass moles concentration. You don't know your moles at the moment, but you know a mass and you can work out an MR. So for phosphoric acid, we're going to have 4 times 16. The phosphorus is 1 times 32, and the hydrogen is 3 times 1, and you can find all of those atomic masses on the periodic table at the end of the paper. And when we add all of these up, we get a total of 99. So now that we know that that's 99, we can now work out the number of moles. So our number of moles is mass over MR. So we've got 7.84 divided by 99, which gives me 0.079 moles. And now I can use that to calculate my concentration. So concentration is moles over volume. So 0.079 divided by the volume, which remember must always be in decimeters cubed. And that gives me a concentration of 0.198 moles per decimeter cubed. And that will round up to 0.20, giving us an answer of C. For question 12, we've got another calculation where we have an empirical formula with a hydrocarbon. So we've got a mass of 7.2 and it contains 6 grams of carbon. So you want to be writing out a table here. So you're going to have your elements, which are carbon and hydrogen, because of course it is a hydrocarbon. You know your masses, which is going to be 6 of the carbon, and for the mass of the hydrogen, it must be the remaining, so that would be your 7.2 take away 6, which gives you 1.2. You know your molar masses are 12 and 1, so you can now work out your number of moles. And your number of moles of the carbon is 0.5, and your number of moles of the hydrogen is 1.2, because remember your moles is mass divided by the MR. And now to make it into a whole number, we're going to take the smaller of the two and divide them. So we get 0.5 divided by 0.5, which is 1, and 1.2 divided by 0.5, which gives me 2.4. Now, of course, I cannot have a 1 to 2.4 ratio for the carbons to hydrogens, because you can't have something that's 2.4. You need to now make this up to a round number. And the only way to make that up to a round number is by multiplying both sides by 5, which gives you a 5 to 12 ratio. So your empirical formula is C5H12, which is B. For question 13, the pairs of substances that contain the same number of moles at room temperature and pressure, well, they give you all of the AR values and they give you the molar volume. So all you have to do here is work out the number of moles of each of them, and there will be one that will match up. So the number of moles of chlorine of 24 decimeters cubed, well, that's going to be 1. And the number of moles of 20 grams of calcium, if you remember your triangles, so your volume, moles, molar volume, and your mass, moles, MR. You use each of these triangles, and for A, the two mole values are 1 and 0.5, so of course they're not the same. For part B, it's 1 and 2, so of course they're not the same. For C, it would be the 1.2 divided by 24, which gives you 0.05 moles, but 2.7 over 27 is 0.1. So our answer is going to have to be D by process of elimination, but we can check that 1.2 decimeters cubed of nitrogen is 0.05 moles, and 1.2 grams of magnesium is also 0.05 moles. So our answer must be D, so because these two have the same number of moles at room temperature. For question 14, we're looking at the maximum numbers of electrons in a 2p orbital in the third quantum shell. So for any orbital, we can only ever have 2 electrons. So that's automatically getting rid of C and D. Remember, the 2p subshell will contain 6 electrons, but each of those subshells are made up of 3 orbitals that can hold 2. And for the third quantum shell, we can have the 3s, which holds 2 electrons. We can have the 3p, which holds 6. And we can't forget the 3d, which holds 10. So our total is 18 electrons. So our answer here must be B. 2 electrons in a 2p orbital and 18 electrons in the quantum shell. For question 15, water reacts with hydrogen ions to form H3O plus ions, and we want to identify the bonding within this. So we're going to be looking at the structure here. So we would take water, and when it bonds with the hydrogen ion, it's going to form a dative bond, and we're going to get an overall positive charge here. So we know that we don't have any ionic bonding because there is no metals here. So that gets rid of C and it gets rid of D. And that leaves us with covalent bonding only, or covalent and dative. And we know to react with this hydrogen ion, as was shown in the diagram, we get that dative bond where the lone pair of the oxygen is bonding. So our answer must be B. For question 16, the shapes of the AlCl3 and the pH3 molecule, well, the best way to do this is draw them out. Aluminium is in group 3, so it is going to have 3 bonding pairs. Therefore, that is a trigonal planar shape. So that gets rid of A and B because that says for pyramidal. And for phosphorus, phosphorus is in group 5, so it has a lone pair, and then it has the 3 bonds to the hydrogens. So we have got 3 bonding pairs and 1 lone pair. Well, obviously both of them cannot be trigonal planar because they have different amounts of the bonding and lone pairs. So we can get rid of C. That leaves us with D, which is correct because anything with 3 bond pairs is trigonal planar, and anything with 1 lone pair and 3 bond pairs is pyramidal. For question 17, we're looking at the polarity of the CCl bond and the polarity of the molecule. Well, we know that a carbon-chlorine bond is going to be polar because we have quite a large difference in electronegativity between the carbon and the chlorine. So we're going to get delta positive and delta negative. So that gets rid of A and B. That leaves us with C and D. So now we need to look at the shape. And a CCl4 is going to have a tetrahedral shape. But this means that each of the dipoles are being pulled equally in opposite directions, which means overall this is a non-polar molecule. So whilst we have polar bonds, we have a non-polar molecule. So our answer is C. And lastly, the empirical formula for this molecule, well, this is a case of counting. So you're going to count each of the carbons and then each of the hydrogens and the chlorines. So we start with the carbons. We've got 1, 2, 3, 4, 5, 6, 7, and 8. Our hydrogens, I'm going to do it in a different colour. For hydrogens here, we're going to have 2 on each of these carbons. We're going to have 1 there with the chlorine, 2 on that carbon. We're going to have 3 at the top, 1 hydrogen there, 1 hydrogen there, and 2 here. And when I count those dots, that gives me a total of 14. And I've got 2 chlorines. Now you can see each of these numbers can all be divided by 2, so they are not the simplest number. So we have C4, H7, Cl. So our answer is B. That's all of the multiple choice questions for the sample paper. If you notice as we go through this, a lot of it is process of elimination, and that's the best way to approach a multiple choice question, is figure out what it's not first, and then look at what you're left with, and generally you'll be left with a 50-50, and you can then use your knowledge of chemistry to be able to determine which one of those two is going to be your correct answer. Check back on our other videos for the remainder of the paper. They'll be broken down by question, and you can have a look at each overall question in the sample paper for Unit 1.